So, this is a proportion. You can cross multiply to solve this. But I want to give you that one idea that will always work. So we're multiplying through by the lowest common denominator. The lowest common denominator, when we look at these, right? They're totally and completely different, right? Two different binomials. So there isn't what's missing from this factor, this entire thing. This x minus 6 is nowhere in this. So I have to multiply by that to get the lowest common denominator. In other words, the lowest common denominator, where should I'll write this here. The lowest common denominator is x plus 2, x minus 6. That's what the lowest common denominator is. That's what I'm going to multiply by. So I'm taking this entire side, I'm taking this, and I'm multiplying it by that. Let's see if I can do this. Oh man, I'm awesome. I'm awesome. I'm doing the same thing on the left because that's the common denominator. But like we showed you on this previous example, or was it? In this one, we talked about how you really only multiply by what's missing from that side. So when you look here, even though I'm multiplying this times this, I'm only going to multiply the part that's missing from this denominator. And that's this part. So essentially, this is canceling this in our multiplication. So I have 6 times x minus 6. Over here, what's missing? The x plus 2 was not in this original fraction. The x minus 6 is, so they're canceling each other out. And I have 2 times x plus 2. And just to cycle back around in case you didn't believe me, this is what sorry, I didn't need to go that far. This is what I would have gotten if I had gone here and here. 6 times x minus 6, 2 times x plus 2. Now again, that's only that option of cross multiplication is only going to work if it's one fraction and one fraction. You can't do that in an instance where we have the difference of two fractions on one side. Unless you combined these to start. Right? You could combine these two fractions into one and then cross multiply. You could do that. It works. But now we're here because we took a different approach. And that has made all the difference. Right? Robert Frost, you guys know who Robert Frost is, right? The Road Not Taken. I took the one less traveled, and it's a poem. Look it up. All right. Anyway. Really? What do they teach you in English class here? What are you reading if you don't know who Robert Frost is?
Romeo and Juliet.
Oh my gosh, that's garbage. I'm just kidding. All right, here we are. So we have a linear equation with variables on both sides. We'll go slow this time. Maybe I shouldn't take for granted that you know how to solve this. Get your x terms together. Move your constant over your variable or your term without a variable. So we have 4x equals 40. Divide both sides by 4. X equals 10. This hasn't come up yet, but it will. So let's talk about it now. When you solve a rational expression, or excuse me, a rational equation, you need to make sure that the number we get is something that I can plug back in. Like this is, when you were first taught how to solve equations, it was, okay, solve, and then plug it back in to make sure that you're correct, right? Solving and checking. You do need to check this to make sure that it will, quote, fit back into your fractions. For example, if we went through this entire process and got x equals 6, let's just say that happened. If we went through this entire process and we got x equals 6, when you look at these two fractions, and this fraction started out, this fraction started out as x minus 6. If I put a 6 here, what would be in the denominator? 0. And that's a no-no. So if we go through the process and we get a value that doesn't work in the fraction, we would have to say that there is no solution, which is a possibility. Okay? More to follow on that when you're in pre-calc, but just so we're clear, when you get your answer, like I got 3, we got 3, sorry, not I got, we got 3. Can I put a 3 here? Sure. That's already a 2, don't need to worry about it. But here, can I put a 3? Yes. But if I went through this process and got 0, I wouldn't be able to do that. I wouldn't be able to plug a 0 in here. So I'd have to say, even though I did all this perfect math, I'd have to say there's no solution at that point. Okay? I think that's all I got on this page.